So continuing in hypothesis testing, we have to kind of take our baby steps in, and then we get really into it toward at the end of the chapter. So we have to first start talking about setting up our hypothesis, because we can't just claim, like I claim that blow dryer at Costco it's not the best one, right? That's my claim. But I need a complement statement, right? Well, what would be the latter, right, would be, well, it is a good blow dryer, and most Americans do like it, right? So that's what we're going to talk about. We're going to talk about, we can make claims, but we also need to have some sort of status quo as well. So the null hypothesis, let me get my highlighter out, and I encourage you to as well, is the null hypothesis is denoted by H sub 0, sometimes said as H naught if you've taken physics. And usually in statistics, we just call it the null. You know, the cool way of saying it is like the null is. And that's the statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference until it is assumed there's enough evidence to indicate otherwise. And we can think of the null as status quo. Like flatlined, right? Nothing. We assume nothing's changed. That's the null hypothesis. The alternative hypothesis is denoted as H sub 1, or sometimes we use the little a or capital A, just because for A for an alternative. But I like H sub 1. I'll be using H sub 1, but in homework you may see H sub A or sub capital A, and they all mean the same thing. And it is exactly what it is. It's the alternative, right? It's the claim being made about the population parameter that is contradictory to the null, and it's a statement that we're trying to support. So I'm trying to say that my claim is that this blow dryer isn't the best blow dryer. All right, the status quo would say, no, this blow dryer is the best blow dryer. That's status quo. My claim is that it's not. And so now the process of hypothesis testing is finding evidence to support that statement. Sometimes you will, sometimes you won't. It's just really up to your sample data, right? And your statistics. Okay, so there are 3 scenarios. Okay, there's 3 scenarios how to set this up. The first one is where the parameter is equal to some value. We assume status quo, right? And always remember that. Status quo. Nothing's changed, right? No change. And the alternative would mean that something did change, right? And so this is called a two-tail test, and we can look at it as something has changed, or there's a difference. So they don't really specify, oh, it's greater than, less than, increase, decrease. It's just literally there's a difference. Like something's changed. I don't know what it is, but something has, right? So then the next one is, once again, status quo. And then we say, well, not only has it changed or difference, but I think the parameter has decreased, right? If we say it's decreased, then we call this a left tail test. And we can say decreased, right, with the less than symbol, so they match up. Also, less than, right? Think of all those synonyms we had during our lab for inequalities. Okay, and then one thing, we call it a left tail test because notice it's pointing to the left. Okay, the inequality symbol. Okay, so then the last one is, again, status quo. So notice all of these are for the null. All 3 scenarios have status quo for the null. The alternative is when that something's happening, right? So now the last scenario is when a parameter is greater than some value or has increased. Notice it points to the right, and so we call it a right tail test. And so you'll see it a lot as increased, right? Greater than, something like that. So some keywords. Okay, so then what does this look like? Okay, so let's do the first scenario. So we'll call this left tail scenario, right? Draw a normal curve. Okay, and then left tail means that we have all the area. So let me shade that. And that means that alpha is the area now to the left. Okay. And just we remember that left-tailed alternative means that some parameter is less than some value. And that's usually given to us. The next scenario is right tail. And if I drew the curve, and that's exactly what you may think, right? Is that all the area is in the right tail. So you can see this alpha is now popping up a lot and more, right? And once again, that means the alternative means that some parameter is greater than some value and usually given to us. The last piece of information they give us, or the last scenario, is the two-tail test. And the two-tail test you have seen before with the confidence interval, where you are finding the sample size. And so here, if it's a two-tail test, that means I'm splitting up this alpha that we had before in the entire left tail test or in the entire right tail test. I'm splitting it into two tails. So I'm taking the alpha and splitting it up, right? And essentially I'm finding like this middle area under the curve. So then you have these two tails. Right, and that's just when we claim that the alternative is the parameter not equal to the value, right? It's just different. We don't know what's happening. We just know something changed. Okay, so this note just talks about what I just talked about, how the null hypothesis you could think of as status quo or nothing has changed. And it's always a statement of equality. And we always assume the null is always supported over the alternative. Until we have enough evidence to show that there's something different happening, then we can say we rule out the null hypothesis and we have enough evidence to support the alternative. So we don't think of things in terms of, oh, like the alternative is right and hypothesis is true, null hypothesis is true, and that's not how we look at it in statistics. We don't look at true and false because we're dealing with statistics and not absolute. We just say like, oh, well, there is enough evidence to support, the statistics showed evidence to support the alternative or support the null, right? So we're going to always look at this in this class as we reject or not reject the null, because we always assume the null hypothesis is supported. And so we'll have a lot of practice at this. So, but just for now, just kind of get it in like, okay, status quo, reject or not reject. Okay, so for each of the following claims, determine the null and alternative and state whether the test is two-tailed, left-tailed, or right-tailed. That's pretty simple. So let's go ahead and read. Let's see if we can find any red flags. In 2008, 62% of American adults regularly volunteer for their charity work. A researcher believes this percentage is different today. So first things first, right? The red flag, right? You see that word is different. And so that should bring you back up here Just saying, oh, if it just says different, it doesn't say decrease, increase, it just says, hey, something's different, it's a two-tailed test. And it looks like this third case here. So the first part is we'll set it up. The null is always the status quo. So what is the population parameter? Well, the status quo says, hey, 62% of Americans volunteer. And that's not going to change. Right? That status quo, that's going to be the same. And so now the alternative, H sub 1, that means that the percentage of American volunteers is different than the 62%. Okay. So the second part is we know that because it's different, we identified that this is two-tailed. Okay. All right. So going to the second scenario with the cell phone call, right? According to a study published in March 2006, the mean length of a phone call on a cellular telephone was 3.25 minutes. A researcher believes that the mean length of a call has increased since then. And so here we can see the red flag. So there's the red flag, says increased. So you go back up here to your table and you see that increased is right-tailed and it's a greater than symbol. So we have the right-tailed scenario here. Okay, so 1i, right? The null is status quo. Nothing's changed. So what is the mean length of a cell phone call? So that the mean time of a cell call is 3.25 minutes. Status quo, nothing's changed, right? But the alternative now says that the mean time has increased from 3.25 minutes. Okay, and so since it's increased, we know that this is a right tail test. And it would have that little area shaded to the right. The last example is the manufacturing process of wine, right? We said the standard deviation of the wine in a bottle was 0.23 ounces. And with new equipment, a QCM believes that the standard deviation has decreased. So this means that the red flag is the decrease, and we know that this is going to be left-tailed. So if we go ahead and write the hypothesis, right, the null is status quo. So what was the status quo? That the standard deviation is 0.23 ounces. Right? That has not changed. Right? And then the alternative says that this standard deviation of wine has decreased because they feel it's more accurate with the new machines, right? Like they're not giving too much over 0.23 ounces or less 0.23 ounces. Okay, and because it's decreased, right, that was our red flag to say that this was a left tail test.